मुश्किलें जितनी आए हिम्मत नहीं हारेगा तू। याद रख तू कौन है, पर्वत को चीर फाड़ेगा तू। पंख नहीं दिखते तेरे पर भर ले तू ऐसी उड़ान। उड़ जा नन्हे पंछी कर दे सब परिंदों को तू हैरान। कोशिशों से मिलती कामयाबी, कामयाबी का तू हकदार है। रास्तों की खाके ठोकरें, जीतने के लिए तू अब तैयार है। ओ रुकना कैसा, डरना कैसा। बात नहीं कोई अब डरने की, कर ले जिद आगे बढ़ने की। बात नहीं कोई अब डरने की, कर ले जिद आगे बढ़ने की।
Good afternoon, Siddhis. I am your host, Priyashi. Welcome to the World Education Day Fair 2022 by Internshala Trainings. You have joined us for the 6th episode of IST Practicals of the Day. IST Practicals is a series of free online masterclasses delivered by industry experts. These 45-minute sessions are all about teaching students important concepts, softwares, and tools. Every IST Practical is an opportunity to experience practical learning. This webinar is about SolidWorks, and our presenter today is Mr. Tayseer Almattar. Mr. Tayseer Almattar holds a bachelor's degree in mechanical engineering and a master's of design degree in international design and business management. He is a believer in the power of design in enabling sustainable business innovation. He is also the founder of TforDesign. SolidWorks is Tayseer's software choice in generating 3D designs. He has been a SolidWorks user for over a decade and has published multiple related online learning programs, attracting thousands of learners from across the globe. I hope you will enjoy this webinar with him. We also have a very special gift for you towards the end, so stay tuned for that. And without further ado, let's welcome Mr. Tayseer.
Hello, thanks a lot for the humbling introduction. Again, my name is Tayseer. And without further ado, I'm going to go ahead and share my screen. Okay, let's get started. My name is Tayseer, as you have heard, and today we're going to be talking about 3D modeling in general, and in specific, we're going to be talking about SolidWorks. So let's go ahead and get started. And the first thing I want to do is to ask you a question. And the question is a poll, and it's going to be, are you familiar with SolidWorks? And if so, are you also a user? So we have the chat that you can share your answers with us, just so we can have an idea of where everybody stands. Okay, so I see a lot of different answers, yes and no, and there's a lot of not yet. So hopefully, maybe after this, you'll end up starting this journey. So now this poll is done. What's better than a poll is, of course, another poll. So here's another poll for you. How familiar are you with the concept or term parametric 3D modeling? Again, you can leave your answers in the chat just so we get an idea of your situation or your familiarity with the concept. You can let us know if you've never heard of it, or if you are a master of it and you can teach it to anybody who wants. So I see there's a lot of different answers. There's a lot of no's for this question. And that's good, because today we're going to talk a lot about that. So understandably, there's a lot of people here for different levels, because I see yes and no's. This session is aimed for beginners, so it's slightly on the basic side of things. And so let's move into talking about our agenda. So here are the things we're going to talk about today. We're going to first talk about what is parametric 3D modeling. We're going to talk about why would you use parametric modeling, and then we're going to dive into SolidWorks. We're going to talk about what is SolidWorks, and then we're going to go into hands-on demonstration on using the software. And then at the end, we're going to have an open floor for questions, which you can ask any question you have in mind. So let's start with the question, the big question of the day. What is parametric modeling? In a nutshell, parametric modeling is the core principles of a parametric software like SolidWorks. What does that mean? In parametric modeling, we are creating 3D models based on relations and logical arrangements. Basically, we're talking about good old geometry. So we have two lines, and those two lines have intersection at one point. That's a parameter. Those two lines are, let's say, perpendicular to each other. This is another parameter. You have other two lines that are parallel to each other. That's also another parameter, and so on. Or you have a line of a certain length of maybe 1 or 10 millimeters. That, again, is also another parameter. It is a sort of logical geometrical arrangement. And the 3D modeling with parametric approach is very ideal for applications that ends up in manufacturing. And so whenever you look around you, just around me here, I have cups, I have a mouse, I have a mic, I have a camera, I have a screen and a keyboard. Very, very likely, a lot of those things around us that ended up being manufactured somewhere and somehow were made using parametric approaches, because those parametric approaches geared themselves toward this sort of applications. And the reason we're talking about parametric approaches before we even talk about SolidWorks is because, again, parametric modeling is sort of the brain behind SolidWorks. And so if you're able to understand, or if you're able to have some understanding of how SolidWorks and how a parametric software functions and think, then learning it will be much, much easier. And it's also going to be much easier for you to take advantage of all the features that are being offered by the software, because you know how the software thinks. So just now, this definition we gave of parametric modeling might not be the best out there. And so to sort of get things going, we're going to do an exercise. And so let's get started with this. You honestly, you don't really need a paper. You don't need any tools like shown in the picture. You just need to be present mentally. This is going to be a very mental exercise. So let's get started with this. And for this, we're going to build a parametric cube. And to start with, we're going to build a parametric square. So let's get started with the parametric square. And for this, I'm going to give you 4 lines. The length of the lines is not defined, so they can be longer or shorter. And I give those 4 lines to you, and I'm going to ask you to make a square out of those 4 lines. And let's say this is going to be a 1 millimeter square. And then, of course, what you're going to do is you're going to take those 4 lines and you're going to do this. And then you're going to give me the square. I'm going to say, thank you very much. You're going to say, welcome. And that's the end of the story. But let's stop here for a second, because for me and you, we are very familiar with a square. Basically, we understand how each of us think. And so we can easily communicate this principle of a square, because we went to school together, for example, and we studied in desks next to each other when the teacher was talking about squares. However, when we look at this from the software perspective, if you take off your hat as a human being and you put another hat in as a software, the square would look something like this. We have 4 lines again, the general shape of a square, but then we have all those red indications. And everything that is in red is a parameter. So each end of 2 lines is merged together. That's a parameter. Those 2 lines have a right angle between them. That's another parameter. There's another right angle here. That's another parameter. There are equal lengths for those sides here. That's another parameter. And then we have a dimension, which is 1 millimeter. That's again another parameter. So this is how a software would look at a sketch of a square. And this is how, when we use a software like SolidWorks or other 3D modeling, parametric 3D modeling softwares, we have to be thinking at the same terms, as in, what are the parameters out there? And for now, I'm going to call this square we have a sketch, right? And this is just for the sake of common language. Now let's take another step, one step further, and we're going to change this square, parametric square, into a parametric cube. And so what we're going to do is we're going to take this sketch we did, we take it to the side, and then we're going to do an extrusion to that square, and then we're going to have another parameter here. That height would be of equal length to the side. Again, that's another parameter, and now all of a sudden we have a cube, right? And for the sake of common language, this idea of extruding our square into a cube, we're going to call that a feature, right? So now we've learned 2 terms, sketch, which is a 2D square, and then a feature, which have transformed this 2D square into a cube. So now one person would come and ask, okay, what's the big deal? That's too much thinking, too much talking into setting up those little parameters here and there, and at the end of the day, we ended up with a cube. Can't the machine be smart and do it for us? And this comes to an important principle when dealing with computer programs, and it is we have to keep in mind that we are talking to machines at the end of the day. Now, machines are really great in executing our imagination and just putting up everything we want. However, we need to be specific in telling the machine exactly what we want, and only then the machine will be able to build it for us. And when we are thinking in 3D modeling and parametric 3D modeling, those parameters we just talked about are the sort of things you have to keep in mind when you are communicating with the machine to describe the shape you want to have. So now let's take one step further. So now we just created a 1 millimeter cube, but now all of a sudden this guy comes to us and be like, we don't really want a 1 millimeter cube. We want a 5 millimeter cube. Now we're in trouble, because we already did our cube, and how about we change it to another cube? And this is where parametric modeling comes into power, this principle and methodology, because now we can go back to our original sketch, if you remember that, and we can go to this 1 millimeter dimension that we put in, and we just double click on it, change it to 5, click enter, and then one parameter has shifted, changed from 1 millimeter to 5, while all the other parameters remain true. This means that this line in the bottom will grow to 5 millimeter. Those merged lines will still be merged. Those right angles will still be right. Those equal lengths will still be equal. And then this extrusion will still be of equal lengths. And then all of a sudden, we have changed the 1 millimeter cube into a 5 millimeter cube. Very quick, very fast, very efficient. Right? And this comes in as the first major advantage of parametric modeling, and that is it makes it so easy and so efficient to go through design modifications throughout our design cycle. Now, one person might come and ask, well, why can't you just make up your mind? You said 1 millimeter cube, why do you change? And if you're asking this question, then you might be missing a very important principle of design, and that is design is very circular. Every time you design something, and if you look around you, of all the products out there, you design it and then you redesign it. And then you end up with something that is good for production or good for to go to the factory. And so this is where modifications are becoming a very essential and key part of design. And when you're doing parametric modeling, this works out very well. And we're going to show this in practice with SolidWorks in few minutes. But now, let's go ahead and ask a question. This is a quiz for you, and this is going to be a questions on parameters. So let's go here, and this is your question. Which of those can be considered a parameter? A dimension, a parallel relation between two lines, a perpendicular relation between two lines, or all the above? Again, you can leave in your answer at the comments so we can see where everybody stands. I see a lot of these, and that is great. And the correct answer for this is D. Okay, good job. Now let's move into talking more about the advantages of parametric modeling. Just now, we've shown in our mental exercise how we were modifying the cube. So now, one of the big advantages we have with parametric modeling is the ease of modifications and adjusting the model through the design and production cycle, which is quite key to the practice of design. Another advantage is it makes it easy to create families of parts that have similar parameters. Let's take an example. Let's say I have this cup right here, and I 3D model this cup of a certain size, and then what I can do is I can take this cup, 3D model it, and then create multiple variations of it. So one of them will be bigger, one of them will be as in thicker, one of them will be taller, one of them is going to be shorter, one of them is going to be thinner, and so on. And I can easily create this entire family of parts by changing a few parameters using, for example, a design table. A cup was a very simple example. Engines have the same thing. Engines often have different sizes. Piston has different sizes. PS5 has different sizes as well. And so all those type of designs, we can call them families of designs, we can easily make with parametric modeling because we're only shifting selected parameters while keeping the rest of design intent. Another advantage is it makes it easy to communicate your design to manufacturing for making, because it's much easier to communicate logical arrangements rather than abstract shapes. And because of those inherent advantages of the idea of parametric modeling, a software like SolidWorks, for example, which we're going to talk about later, came to adapt to cater for the those specific industries and for the specific design applications. For example, we can now design a part, and then we can assign a structural material for the part. Is it going to be aluminium? Is it going to be wood? Is it going to be rubber, etc.? We can easily generate engineering drawings. We can design a part and then take that, export all the design elements of it into a 2D engineering drawings, which we can then send over to manufacturing to be for the design to be made. Another advantage is we can have a lot of design evaluation tools. For example, within SolidWorks, we can have mass analysis to identify the expected mass of the expected weight of the design. We can figure out its center of gravity, its moment of inertia. We can also conduct thickness analysis, curvature analysis, symmetry analysis, and so on. Another thing that softwares came to adapt to is simulation. Now you can simulate, or with simulation, basically you can predict how a specific design would behave in real life. For example, I designed this phone right here, and then while I'm still designing it in the 3D software, I can do a drop test on it with simulation. So then this drop test will tell me if the phone will break to a reasonable accuracy, if the phone will break or not if I drop it. And if it breaks, I can remodify the design and then do the test again. And all this happens within the software environment without even investing in prototyping. You can imagine how much savings and how much time can this save. Again, both time and money. So now we know parametric modeling, we know how softwares came to adapt for it. Now we can move and start talking about SolidWorks. So what exactly is SolidWorks? SolidWorks, in a nutshell, is a 3D CAD software that utilizes parametric modeling approaches. Everything we talked about are features and principles that SolidWorks is using in its operation. So with this, I have another quiz for you, and that's going to be a question on SolidWorks. So let's move into our quiz panel and move into the second question. Simple question. What is SolidWorks? Is it a 3D CAD software? Is it a 2D CAD software? Is it an animation software? Or is it a graphical design software? Again, you can leave your answers in the comments so we can see what everybody thinks. I see there's a lot of different answers for this question. Most people said A, and A is the correct answer. SolidWorks is fundamentally a 3D CAD software. However, it does have really smaller elements that covers animation, and you can use it for graphic design, but that's not really the intention or the main purpose of the software. The main purpose of the software, the main goal of the software is being a 3D CAD software. Okay, now let's move into demo, right? So let's say you have a neighbor, and your neighbor came to you and he said, that neighbor is he's a person, and he came to you and he wanted your help. And you would say, sure, how can I help? And then that neighbor pulls up a napkin from his pocket and give you this particular drawing of a table. And he's asking you, that he wants to have a 3D visualization for this table, and he wants to make this table out of maple wood, and he's wondering how it's going to look like, and he's also wondering how much weight will the table weigh, how many kilograms. So then you take that napkin, and then you go home, you open up your computer, and then you open up the software, SolidWorks, and you start working on this table. So let's go ahead and do that. So this is the software interface. This is what you get when you first open the software. And what we're going to do now is we're going to open up a new file. So I'll go to new, just like any other software, and then click on it. And now we have three different options. We can either create a part, we can create an assembly, or we can create a drawing. So let's go ahead and create a part. So I'm going to select part, click OK, and now we have this interface popping up for making up a part. And this interface is segmented to different parts. So in the middle here, I have what I often call canvas. This is where our 3D models will show. And on the left side, we have our design tree, and this will show the collection of all the features we apply. And on the top, we have the command center or the command bar where all the commands are located when we are putting them or when we are using them. So for now, I'm going to select a plane and then do a sketch and then do a feature. Just like we did in our mental exercise, when you're building 3D models, we keep going on the same cycle of sketch, feature, sketch, feature, sketch, feature. So let's go ahead and start with a sketch. I'm going to select the top plane for this, click on it, and then click on this little command here that says sketch. And now I'm going to create a sketch of the top of that table. And the top of the table, as seen in the napkin, is a square top with a side of 500 millimeter. So I'll go to the command manager here on the sketches and go to the rectangle shortcuts, select one type of rectangles, click on the center, and then expand, and then click again. And now we have a sort of triangle. Now what we want is a square with a side of 500 millimeters. So what I'll do is I will dimension one of the sides. So I'll go to Smart Dimension, click on that, and then click here on this side, and then dimension it to 500 by typing in 500. And so now we have one side that's 500, but the other side is still not really defined. And what we want, since we want a square, we want both sides to be the same. So what I'll do is I will select those two sides. So I select one side, click Control on my keyboard, select the other. And then here on the side, we have relations. And those relations are parameters, right? So I'll go ahead and select the equal parameter. And once I do that, the side will become equal to this top one, which is equal to 500. Now you can also notice those green marks on our sketch. All those green marks are different parameters that govern our sketch, which in this case is simple square. Now we're done with the square. So we're done with the sketch. Just like we did on our mental exercise, we're going to move and apply a feature. So I'll go to Features, use the Extrude feature, and then type in 50, which is the dimension we were given in our napkin. Click on the check mark, and we have our top of the table ready. Now we're going to do the same thing for the 4 legs of the table. So we're going to do the same process. We're going to do a sketch, and then we're going to do a feature. So I'll go ahead and select this surface for a sketch. Click on this sketch command, and then sketch another rectangle. I'll go a bit quicker this time since we already know how to do rectangles or squares. So I did my rectangle command. I'll go to this corner and then again do 2 clicks. We have another rectangle and I'm going to dimension it, which we were given to be 50. So I'll dimension one side to 50. And then I will apply a parameter to have the other side to be 50 as well. Now we have 4 legs, and those 4 legs are identical to each other. So now instead of doing 4 legs, I will just do one and then mirror that sketch toward the other side. To do a mirror, we need a reflection line. So I'll go ahead and sketch 2 lines. Again, the line command from the top. I'm going to sketch one line like this and another line like this. And then back to my commands, I will select the mirror entities command. And now we get this options, as we see on the left. Entities to mirror, I'm going to select my rectangle or my square, sorry. And then I will mirror them about this line right here. And then we can see a yellow preview on the side. I'll click on the green check mark and it's done. Now I want to mirror both of those to the bottom. So I will do the same thing. I'll do mirror to entities to mirror. I will select both rectangles or both squares, and then I will mirror them about this line here. And again, we can see the yellow preview. Click on the green check mark, and we're done. Now we have all the legs for our table. And again, if you notice all those green symbols, all of those are different parameters that are existing within our design. Now, let's say that, maybe we got confused. The table, the leg is not 50 millimeter, it's 40 millimeter. Well, it's fine. We can simply change that. So let's try this out. I can double click on the 50, change the 50 into 40, click on the green check mark, and you will notice that all the 4 squares have automatically shifted because all of them are constrained and ruled by specific parameters that made them all update to be like that. So again, just to emphasize on the parametric approach. Now I will apply a feature. So I'll go to features. I will use the extruded boss feature, and the leg has a length of 450 millimeter. I will click on the green check mark, and we are done with our table. Simple and easy. Now, the table is supposed to be made of maple wood. So let's go ahead and change this material into maple wood. So I'll go to materials, right click, edit materials, and then we get a new window with a list of materials. And what I can do is I can go to the search and type in maple. And then we have maple wood right here. Click on that, click on apply, and now our table is made out of maple wood. Okay, so how much weight will this table weigh? I can go to the evaluation tab, go to the mass properties. Again, this is one of the analysis tools we have in our disposal. And now all of a sudden, we also have the mass of the table. If we are to make it to this size, it's going to weigh 8,330 grams, which is about 8.3 kilograms. That's quite a heavy table. So now we give this information back to our neighbor, and then he goes like, you know what, that's too heavy. I want to change it. I don't want it to be 500 millimeter on the side and the top. I want it to be 450. Again, we say, okay, that's simple. Remember what we did in our mental exercise. We go back to our sketch. So here in the design tree, I can click on the sketch. Here is my 500. I can double click on that, and I'll change it to 450, or let's just change it to 400. and then click on the green check mark. Now I'm going to rebuild the model, this traffic light on the top, and the table just got smaller. Notice when the table got smaller, all the legs remained at the same place. Basically, the table remained fully intact, exactly the way we wanted, or exactly the way we set the parameters to be. Now I can find the mass again, and now the mass of the table is about 606 kilograms. That's much better, and now we can go with this. Now, let's say we want to make a drawing that we can just print out with the dimensions and then give it to a person who would make the table for us. For this, we can simply use the drawing functions. So let's go ahead and do a really quick demo on the drawings. So I'm going to save this file right here, and then I will start a new file. And this time I will select drawing. Now we get this slightly different interface. First, we can select the type of sheet we want. So I'll just keep it to the first one. And we get our sheet. And here on the side, we have the table we just made. So I'll just double click on it, drag it in, click, and then just take the mouse up, click again, take the mouse to the side, click again, and we have our drawing views, the front view and the top view. And now I want the dimensions to be here in my drawing, so I can directly export those dimensions I inputted in my 3D model into the drawing. An easy way to do this is to use this model item function under annotation. So under annotation, I can go to model items, click on that, have the source as entire model, and then click on the green check mark. And guess what? We have a drawing with dimensions. We can just do some housekeeping to make the drawing looks a bit more attractive. And now I can go ahead, I can print this drawing directly. I can give it to a carpenter, or I can give it to a factory, and they can directly make this table for me with those particular specifications that I demanded, or as demanded by the napkin. So this was it for our very short demo on making the table and modifying the table and then making a drawing for the table. And notice how quick you can do designs, and you can quickly also make drawings that you can use for communication or manufacturing or for archiving. So now let's go ahead and go back to my presentation, because there are a few more things that I wanted to talk about with you. And the first thing is, I wanted to have a discussion on complexity versus simplicity. Right. So in essence, complexity is a combination of simple steps. And this is really important to understand and realize. So the table on the left, we just created in a few minutes, and it's quite simple design, and it has only 2 features. Now, on the right, we have a rotor for a turbine. And this rotor, compared to the table, looks a lot more complicated, a lot more complex. However, it's only simple steps done multiple times. So this rotor was done with 11 different features, 11 simple features, just like we did in our table. So that's your way of understanding complexity when it comes to how you design a 3D model of a certain type. Now, if you want to make something even more complex, you can have an assembly. So now this assembly of a full turbine, and you can see the rotor that we just showed you right here. And there are multiple rotors. There's a big one, and there's 3 smaller ones, and a lot of different parts. Most of them are simple parts, put together in an assembly, and with that we can end up with a exponentially more complex design. Again, that's how you should think of complexity. Now, it's a quiz time. So let's go back to taking some quizzes, just so we make sure you were paying attention. So the first question is this: what types of files do we have in SolidWorks? We have a part file, a drawing file, assembly file, or all the above. Again, you can let us know your answer in the comments. Okay, I see a lot of these, and that is the correct answer. Next question. How do we start building a 3D model? A, with a 2D sketch, or B, with a 3D feature? Again, remember the mental exercise we did at the beginning, and also the demonstration we just showed using the software. Again, you can type in your answer at the comments. Okay, I see a lot of A's, predominantly A's. That's good. It means that you were paying attention. And the answer is A. That is correct. Now let's move into our last question for the quiz. And it's this. It's a statement. Dimensions built on the 3D models are automatically reflected in the 2D engineering drawing. Is that a true statement or is it a false statement? Again, remember the table we just made. Okay, I see a lot of A's, and that is the correct answer. All the dimensions that are inbuilt in the 3D model are reflected in the 2D drawing. And if we want to update a dimension in the 3D model, the 2D engineering drawing will automatically be updated as well. And that is a very good feature that makes those softwares very powerful. So let's do a wrap up. So let's just wrap up what we talked about, and then we're going to have some space for a few questions as the time allows. So what did we learn today? First of all, we talked about parametric modeling. We talked about what exactly is parametric 3D modeling, and we talked about why we would use it, the advantages of it, and also how softwares came to adapt to it. We then talked about SolidWorks. We talked about what is SolidWorks, being a 3D CAD software, and then we ended up with showing the basics of using SolidWorks, and we did this by 3D modeling a simple table and then creating a 2D engineering drawing for that same table. So that was it for what we covered. I hope that was useful. And now we can have some time for questions, depending on how much time we have. Again, you can type in your questions in the comments, and then we're going to see how much we can address.
Thank you for the amazing webinar, Tayseer. We can now start with the Q&A round. But before we open the floor for our audience, I have a question for you. So as someone new to this domain, today's webinar has been a great start for me, and I've certainly learned a lot of new things. As someone who's eagerly interested in learning more, what is the right path for me?
Okay, so if you are interested in diving in deeper on this subject, we've actually constructed two comprehensive training with Internshala that you can find them at the Internshala training platform. We have a beginner program on SolidWorks, and then we have an advanced program on SolidWorks. The beginner program will take you from the very basics and will enable you to build relatively complex 3D models of whatever you imagine. And then the advanced program will take you even further to building more complex models, but will also addresses a lot of design optimizations, those including creating variations, creating configurations, design tables, equations, and so on. So if you're interested in pursuing this further, a very, very good start is to check out Internshala Training and check out those two particular programs.
That's right.
Go ahead.
For all the Ziddis here today, Internshala Trainings is offering a special discount on the account of our World Education Day Fair 2022. Visit the link in the description and use code WEDF to avail an extra 10% discount on our SolidWorks training. Also, for everyone who's asking about participation certificates, yes, we are giving participation certificates to all the registered attendees. So if you haven't registered till now on our website, you can still go and visit the link in the bio and register yourself for the World Education Day Fair 2022. We are now opening the floor for questions. We will be taking 4 to 5 questions. I request everyone to type in their questions in the comment section for World Education Day Fair 2000.
Okay, so let's go ahead and address some questions. And again, you can type in your questions from the on the comments, and we're gonna be taking some questions from there. Again, there's a lot of questions out there, so I'll just go ahead and do some random selection. So I see some people are asking about the computer configuration for SolidWorks. For you to find those out, just you can go to the official SolidWorks website and you can find out the specific configuration that are required for the computer. You don't really need a super strong computer, a super powerful computer to run the software. However, there's a lot of requirement that I can't really remember. So they're listed in the SolidWorks website. Check this out, and then you can test out your computer. Okay, a lot of people asking about the different softwares on the 3D space, as in what software should I use? And for this question, there is really no correct answer for this question. What I would suggest you to do is you should do your homework and look up the industries around you. You can go to job post websites that have job posts and just look what the industries around you are using for what software, and then you can decide based on what's used in your area or what's used in the industry you're looking into. It's very different from one industry to another. It's also very different from one geographical location to another, as in, which one would you use? A lot of the softwares are quite similar. So if you learn, let's say, SolidWorks, you can easily transition to other parametric softwares. Statistically talking, as in today, SolidWorks is the most used within the professional environment, as in terms of number of companies that adopt, specific software over the other. However, again, it's really, really different, and I would always suggest people to do some research before figuring out what might be your best first step into this planet of 3D modeling. Some people are asking about where to get the software from. There is an evaluation software version that you can download directly from the SolidWorks websites. Otherwise, there are also different versions like the maker license. There is a student license that you can capitalize on them if you're only using it for learning and not for commercial purposes. Also, you can check out universities a lot of times offer the software for their students. So you can check out with your university if the university itself can help the students in giving them those licenses. Someone is asking if SolidWorks is good for making maps. That's an interesting question. I mean, you can make whatever you want with SolidWorks. You just have to keep in mind that each software is more optimized for one application over the other. So depending on the type of map you're making, maybe SolidWorks would be the best option for it. Okay, so
I think we have room for one more question. So I think this would be the last.
Okay, let's pick one more question. There's one person asking about the best place to learn SolidWorks. Check out the Internshala training. We worked really hard on making those particular programs. Okay, one more, right? Let's take one more question.
Yeah, sure.
Someone is asking about how to use SolidWorks to land, to get more opportunities after. For this, you need to consider a lot of different things. First of all, SolidWorks is a tool that should enable you to do other things. It's just like Photoshop, for example, is a tool to make good pictures, but then you have to think of what's after you learn SolidWorks. There's some things that can be helpful. For example, you can have a portfolio, a design portfolio that can help demonstrate your skills, and SolidWorks can distinguish you from other purposes as well. But with SolidWorks, you should also think of the particular industries and what each industry requires in terms of specific applications. And you need to do some research on that. There's no solid answer that I can give to everybody, unfortunately. So again, research is key. Okay, I guess that's our last question.
All right, that's all for today. Thank you all for joining. The closing ceremony of the World Education Day will commence at 6:30 p.m., where Rahul Ram from Indian Ocean Band will be performing live. He will also be taking some audience questions. So subscribe to our YouTube channel and press the bell icon for updates regarding the session. Hope to see you guys there. Bye-bye.
Okay, thanks a lot for joining.